Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. I received comments from my viewers to explain CD4013 IC. It is CMOS dual D-type flip-flop. What is D-type flip-flop? It is a logic circuit which works on some conditional inputs. What are that? Any D-type flip-flop, it have D input, that is called data input, and it have Q and Q bar outputs. It have two outputs. What is the condition here? The condition is clock input. When its clock is low, this is in disable state. When its clock will move to rising edge, it will start from 0 to high. At this point, any data. What is data? That is name of voltage. Either it is logic low or logic high. What is logic low? That is the lower limit. We can say if we are using in 5 volt condition, maybe it is around 2 volt, 3 volt, like that. And if we are using a 10 volt, 15 volt, this level will change. It will depend on the input voltage level. This IC, its input voltage supply volt, it can be used up to maximum 20 volt. Normally it is used 3 to 15 volts. Any voltage, either it is logic low or logic high, it will transfer to Q, and Q bar is complement of Q. We can say if here is data 1 at this period, the condition is that the clock must shift its level from low to high. At that time, it will transfer this data to Q. Same time, when we are shifting data, it will invert this signal here. If it is high, it will low. If it is low, it will high. In CD4013, it have two additional inputs, that is called set and reset. This set and reset, these are two special inputs in this IC. Anytime either D is available or not, clock is high or low. If we turn on set to high, it will turn on Q high. If we will turn on reset high, Q bar will high. This IC have two logic gates inside. Flip-flop number 1, flip-flop number 2. The first, that is pin number 5 input, that is data input. Pin number 3, that is clock. Pin 4 is reset 1, pin 6 is set 1. So this is one portion and this is the second portion. In first portion, Q and Q bar outputs are from pin number 1 and 2. Pin numbers are marked here. The second flip-flop in this side. And if we see this data sheet, it will give some good idea. This is one flip-flop and both are independent from each other. This is separate, this is separate. And here is the truth table. This is clock. We can see the clock is at rising edge. Data at D input will transfer to Q output. Data at D input, whatsoever it is low, it is high, it will be transferred to Q. And if data is high, Q will high. This Q bar will opposite to Q. If data is going low, there will no action. It will last state. It is called memory. So it will latch. So this is the reason this IC is called D-latch. When clock is low, it will remember its last condition. Any condition which was stored in this condition, either it was low or high. When the clock is low, it will not change any condition. Q will remain Q and Q bar will remain Q bar, which was the last condition. And if clock absent, don't care, data, don't care, reset is high, Q bar will high and Q will low. And if set is high, Q will high. If both inputs are high, both outputs will high. Let's make this circuit practically. We have CD4013 here. I will place in the project board. This is cut side and here is pin number 1. We will apply positive 5 volt. We can use 3 volt to 15 volt power supply, but this time I am using 5 volt. I will inject low voltage supply here and positive voltage here. At both outputs I will use one resistor and one LED, 330 ohm resistor. I connected cathode to the resistor and we will connect this end to ground. Q1, the first flip-flop Q output, that is pin number 1, so we will connect to this LED. First output to this LED, so it is Q. Pin 2, that is Q bar. I combined the grounds and this time the both LEDs Q and Q bar are high. Why these are high? Because set and reset are floating inputs. I will connect at each input, we will connect 10 kilo ohm resistor and we will apply signal here, positive voltage here, and this is the signal. All inputs, data, clock, reset, set, will in this configuration. So I will connect one resistor at each input. We can see pin number 6, that is set 1. When I will connect set 1 to ground, this is now off because reset is still floating. So we will connect 5, 6 and 4. Number 4 pin we will connect to. Now we will connect one by one to high. Now I will turn on data pin high, that is pin number 5. We will put this pin to high. Now applied data pin to high, I will connect clock to high, pin number 3. Now pin 3, when we will connect to high, it will change its position. Yes. Then I remove the clock. Now clock is free, pin 5 is high. When I connected clock pin to high, it shifted the position. Now I will connect data pin, D pin to low. There is no change until I will give a clock pulse high. Yes, now it is changed. So this is D function, D latch. When we can see now data is low. As we discussed here, this is the condition. The data present at D pin will transferred when clock signal will go low to high. This time it is low because we connected a pull down resistor. When the clock pulse is low, there will no effect of data change to the outputs. Data will change on the clock pulse. Now I will change data again to high, and when I will turn on the clock pulse high, the data will swap. Now if the clock will change, there will no change because data pin is high until the data is low. Now the data is low, the clock is high, it will not affect. When we will apply high pulse rising edge to the clock input, it will turn on the Q output. Now the set and reset. Pin 6 is set, and pin 4, this is pin 6. Pin 6 is set. When we will connect pin 6 to high, that is set input, Q will high. And if I will place reset pin to high, Q bar, this pin will high. We can see reset, set, reset, set. Set pin, that is pin number 6. The same way we can check the second portion. It is the same. In this portion, data present at D pin will go to Q, and Q bar will inverted. Either it is low, either it is high. When this position will occur, it will transfer the data. And when set is high, Q will high and Q bar will inverted. And if reset is high, Q will low, Q bar will high. And if both inputs are set and reset are high, the both outputs will high. If you check here, this is pin 1 and this is pin 2. These are inverted outputs. Clock pulses are here, reset and data and set pin. Set and reset are directly driving to the output stage. If this is high, it will toggle the output flip-flop. So this is the truth table. When clock will high, data will transfer to Q. When clock will high, if data is high or low, it will transfer to Q output. When data is low, it will store the last memory condition. Any condition, any data, if it is high or low, don't care. Just only we need to consider the data and clock. This is clock input and this is data. If data is high, on rising edge of clock, data will high, and after that it will not change any condition. When data will low, when the clock will high again, it will change the output condition. It will latch the output. I hope you enjoyed this video. If it is informative, hit the like button. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.